Okay, it says analyze this as the steps 1 through 7, but I'm just going to kind of talk to it the way I would do it here. So first of all, this has a parent function, this, but then it's got a line added to it. So this parent function looks like this, but if we add it to a line that looks like this, it's going to, this line is close to 0, so it's not going to add much height to this. But here, where this goes close to 0, it's going to get closer and closer to the line, and it's going to, this is going to pull this down, so it's going to go something like this. But it's still going to have a vertical asymptote at x equals 0. It's going to have a oblique or slant asymptote of y equals x. And if you don't get it from that, we can do this. We can get a common denominator here, which would be x squared over x, that's another name for x, plus 1 over x, so we get x squared plus 1 over x. Numerator degree is higher than the denominator. If I divide this into here, I'll get x squared plus 1 divided by x goes in x squared. Now, draw the line, change the sign, add, and I get 1, and divide by 1 over x. We get right back to what we were, but that's our oblique asymptote. That's kind of confirming how that comes out to be this. Alright, so I've pretty much done everything here. Oh, we should find x-intercepts. That would be a y-intercept. Let's do that. Y-intercept means make x be 0. Can't do that. None. X-intercepts means make this fraction numerator be 0. Well, that's squared plus 1. It can't happen, so there's none. So there's no x-intercepts or y-intercepts. Doesn't cross those. Has this slant asymptote of y equals x. And it has an oblique one, and we have a vertical asymptote of x equals 0. And so the only way we're really going to get much information on the graphing is plug in points. If I put in 1, I get 1 plus 1, which is 2. At 1, it's at 2. And at negative 1, it's at negative 2. And it's got to go towards this asymptote, and it's got to go towards this asymptote. So 1 here, 1 there, got enough labeling on it. This is y equals x. This is the line x equals 0. And there's no holes, and that's what it looks like. That's 45. Now let's go to 50. 50 is f of x equals 2x plus 9 over x to the third. So, since this has already been divided, and that's our oblique asymptote, y equals 2x, and this goes to 0. X can't equal 0, so that's the vertical asymptote. We can't put in 0, so there's no y-intercept. It says right here, can't have a y-intercept. And x-intercepts, let's see, if I make this be get a common denominator, that'd be 2x to the fourth over x to the third, multiplying by x to the third over the x to the third, plus 9 over x to the third would add together to look like that. And this is always positive, and if you take it times 2, it's still positive. And if you add 9, there's no way it's going to be 0 or negative. So there is no x-intercepts. So let's draw what we know so far. Vertical asymptote at 0. Horizontal asymptote of y equals 2x. So if I go over 1, it goes up 2. With the y-intercept is 0. And close to this axis, this is always positive, and if x is positive, this is positive, so it's got to go off to positive infinity. And since there's an odd number of factors at 0, it has to go the opposite on the other one, so that goes off to negative infinity. And where does it go in between? So if we put a half in here, we get 1. 1 plus 9 over a half cubed is 1/8. So 9 divided by 1/8 is 70. 9 divided by 1/8. 1/8 goes into 9 72 times. So we get 72 plus 1, 73. So at a half, it's at 73. Way the heck up there. And it's got to do something. Let's put in 2 just to see what that is. 9/8 is 1 1/8. And 4 plus 1 1/8 is 4, 5 1/8. So it comes down and goes through there. And so it does something similar, so down here someplace. Oops, goes closer to this one and closer to that one. There we go. And next one is 51. 51 is a graph that goes up like this, comes down like this. This is horizontal asymptote of y equals 1, and vertical asymptotes at 2 and at -2, and it does this. So that's what it looks like. Find a rational function that fits this. Well, to have vertical asymptotes at -2 and +2, the factors in the denominator have to be x plus 2 for the -2 and x minus 2 for the +2. And to have a horizontal asymptote that's not there, it has to have the same degree in the numerator. This is x squared. So we better put something in the numerator that's x squared. So let's just put x squared, and then we have to have the leading coefficients have a ratio of 1. So that's 1x squared over 1x squared, whatever that multiplies out. So that would have that, and so that's probably good enough. Let's see, and this would have, if x was 0, y would be 0, so that would go through 0, 0. So this is probably good enough to get it. Let's take a look at that on the calculator. So clear, we got to put x squared divided by parenthesis x plus 2, close parenthesis, open parenthesis, x minus 2, close parenthesis, graph. And let's do it in Zoom 4. Pretty much what it looks like. Next one is 61. 61. What's that one ask us? A can in the shape of a right cylindrical, so required to have a volume of a can, a right cylindrical can, has a volume equals 500 cubic inches, and the bottom is made out of the material that costs 6 cents per square centimeter. Oh, this is cubic centimeters. cm, so, or 500 cms cubed, either way. The area, the bottom area is 6 cents per square centimeter, and the sides are out of 4 cents per square centimeter. Total cost of the material. So let's see, the top and bottom are out of the 6 cents. So the top is pi r squared. That's the area of the bottom and the top, so there's two of them, and whatever that area is, it's times 6 cents, so times 6 cents, and we get the cost of top and bottom is 6 times this in cents, so that'd be 12 pi r squared cents. The cost of the sides, well, that would be a rectangle if you unwrapped it from around the side, which is how long? Well, a perimeter of the circle is 2 pi r times the height, so that would be 2 pi r h times 4 cents. So cost of side is 8 pi r h cents. Now, it says the wood has to have a volume of 500, and the volume of a can is area of the base pi r squared times the height, and that has to be 500 always. So h is 500 divided by pi r squared. The volume is pi r squared h, and it always has to be 500. So if you divide it by pi r squared, we've got something that stands for h. So we can change the cost of the side to 8 pi r times 500 over pi r squared. The pi's cancel, one of the r's cancel, and so now we get it to be 8 times 500 is 4,000 over r. So the total cost is going to be the cost of the bottom and top, which is 12 pi r squared, plus the cost of the side, which is 4,000 divided by r. Okay, and that's the total cost in terms of r. And for what value of r is it cost a minimum? So what does this look like? Well, we don't really have to do what we've been doing here, but this is a hyperbola, but then this is going to be a parabola, so it's going to be kind of a funky shape here. So we'll go to y equals, and we'll type in 12 pi x squared plus 4,000 divided by x, and then we will we're going to have to graph probably and change our window, but let's just do zoom 6, and we're probably going to not see a lot here. So zoom out, maybe 3, enter. Over here we don't care about negative r's, so let's change our window to be from 0 to 40. We don't care about negative cost, it's the positive cost, so I'm going to start y from 0 and go up higher to like 400. And we're not seeing much there. Let's try zoom fit, see if that shows us anything. Oop. Zoom 0. And there we finally got something. The minimum looks like it happens in here. So let's get into there. Let's cut this down. It went up to x max of 40. Let's get it back to 20. And y min, let's go to 0. And it had to go up to 60,000. So we don't need to go that high. Let's go 40,000. Marking it every 1,000. And 20's there. So now let's graph. So it hits a minimum somewhere around, see, the x direction was every 1. So somewhere around 3 to 4. So I'm going to look for a minimum between 3 and 5, and I think it's 4. And it says the minimum is 3.767. So that's the radius of the can, and it will have a cost of 1,596 cents, or $15.96. Okay, tricky problem.